Have you ever wondered how a machine learning model learns from data? Well, wonder no more, as today we dive into the fascinating world of linear regression, an essential technique in machine learning and data science. Linear regression, in simple terms, is a statistical method that allows us to study relationships between two continuous variables. Our goal is to find the best fitting line through the data points. Output. In our quest to find this best fitting line, we encounter an essential concept known as the cost function. Picture the cost function as a measure of how wrong our model's predictions are in comparison to the actual data. One popular cost function used in linear regression is the mean squared error, or MSE. It calculates the average squared difference between the predicted and actual values. The lower the cost, the better our model's performance. But how do we go about minimizing this cost? Enter gradient descent, the optimization algorithm that helps us find the minimum of our cost function. The idea is straightforward. Start at a random point on the cost function curve, calculate the gradient or the slope of the curve at that point, and then take a step in the opposite direction of the gradient. This process is repeated, updating our model parameters each time until we reach the lowest point or minimum of our curve. Yet determining the size of these steps is crucial. This is where the learning rate comes into play. The learning rate controls how big or small the steps we take are. A high learning rate might make large jumps, potentially overshooting the minimum, while a too low learning rate might result in tiny steps, causing the algorithm to converge slowly. Therefore, selecting an appropriate learning rate is a delicate balance and a crucial step in effectively training our model. With these elements combined, we can optimize our linear regression model. The cost function, gradient descent, and the learning rate work together in an iterative process to find the best fitting line, minimizing the cost function, and thereby improving the model's performance. In summary, understanding these concepts is vital for effectively training linear regression models. The cost function measures the performance of the model, the gradient descent helps to minimize this cost, and the learning rate determines the size of the steps taken towards the cost function minimum. Now, don't just take my word for it. Apply these concepts, experiment with different learning rates, and observe their effects on the model training. There's a wealth of resources available for a deeper understanding of linear regression and its optimization. So, go forth and explore the intriguing world of linear regression.